Welcome to the fifth demo on static routing. This video demo covers IPv4 Floating Static Route. This would be the topology to be considered on the Floating Static Route video demo. Let's move on to our demo. Okay, so on this video demo, so we will be talking about floating static route configuration. Okay, and I'll show you how to configure floating static route on R1 and R3 here. Okay, so if you have not seen the video about the static routing, you could go ahead and check it out. Okay, now the floating static route has the concepts of primary route and a backup route or a standby route. Okay, so when you say floating static route, we will be doing configurations of the link that will be the primary link, or shall we say an active link, and a backup route or a backup link, or shall we say the standby link. Okay, so when the primary link goes down, okay, so what will happen is the backup link will take good care of the connection. Okay, now on this video demo, we will be configuring the floating static route on R1, having the 10, 10, 10, 0 here as the primary link between R1 and R3, and their backup link or backup route on 192.168.1.0 and 172.16.2.0 for R3 and R1 respectively. All right, now this video demonstration assumes that you already have configured all the IP addresses here. Okay, so we already have configured IP address for PC1, PC2, and PC3. Okay, now on the router, let's just check. Okay, so if we have successfully configured the IP addresses on all the interfaces. All right, so in here, so enable, you've got show IP interface brief here. Okay, and if you will observe, the three interfaces are set to up here. All right, now let's do the same on R2 here. Okay, with CLI. Okay, so you're gonna have here. Okay, so enable show IP interface. All right, brief. So we have three interfaces also configured, and the status are up and up. All right, so also with R3, let's check this. Okay, so enable show IP interface brief. All right, so you'll have show IP interface brief. So you'll have this up and up. Okay, so we could also check the routing table, show IP route. So there is no static routing configured. Okay, so also with R2, we'll have show IP route here. Okay, and on R3, you also have show IP route. Okay, so we're ready to go. Let's start the configuration on R1. Okay, so based on our requirement, we will be configuring 10.10.10.0 to be our primary route or primary link. Okay, so to do that, that would be configure terminal. Okay, IP route, for instance, all traffic going to the remote networks would be using the default route, for instance. So let's say we've got 0.0.0.0 here, 0.0.0.0. I'm going to set it on the 10.10.10.2. Okay, this is my primary link. You could include the administrative distance. Okay, but the default is 1. So let me just use the default here. Okay, so also I'll be setting 172.16.2.2, okay, as my next hop interface or next hop route or IP address for the backup route. So that would be 172, right? That's 16.2.2. Okay, having an administrative distance of 5. All right. Now I'm done with my configuration on R1. So let's have do show IP route here. Okay, and with do show IP route, as you can see here on the routing table, any packet okay, distinct for the remote networks will be forwarded to 10.10.10.2, which is this one here. All right. Okay. Now let's do the same on R3. Okay. So to configure our R3, so we are going to set also the 10.10.10.0 network as our primary link. So to do that, you'll have here configure terminal. All right. So IP route. You've got 0.0.0.0, 0.0.0.0. Okay, so the next up IP address would be the 10.10.10.1. Okay, using the default administrative distance of 1. Now, my alternate link or backup link would be, okay, so at IP route also 0.0.0.0, 0.0.0.0. This time I'm going to set it on 192.168.1.2, which is on R2 here. All right. So on R2, and my administrative distance, let me set it to 5. All right. So viewing the routing tables, so you've got do show IP route. You can see that the primary link is via the 10.10.10.1, which is between R1 and R3 here. All right. Okay. So the next thing is to configure R2. Okay. So on R2, let's do the configuration for static. All right. So in here, so configure terminal. So simply your IP route. So you've got 172. All right. That's 16.3.0, 255.255.255.0, and that is via 172.16.2.1. All right. So also going to 192.168. All right. So 2.0 here. So that would be IP route 192.168.2.0. You've got 255.255.255.0, and that is via 192.168.1.1. All right. Okay. So our concern here is just PC1 and PC2 network. Okay. So we want to see if we are going to shut it down, it will use the alternate route. All right. So, but then take note that there is a third remote networks on R2, which is 10.10.10.10.0 or 10.10.10.0 here. Okay. So let's configure that also. Okay. So just to complete the demonstration here. All right. Though we will not be using it on our requirements. So that would be IP route. Okay. So something like 10.10.10.0 here. Okay. So 255.255.255.0. So take note that we have two possible routes to reach 10.10.10.0 here. So which is either via 172.16.2.0 network or 192.168.1.0. Okay. So you might want also to configure having such a floating static route on R2 here. But then again, our demonstration will be limited only on PC1 and PC3 here. All right. So to do that, so let me just do it. So this would be example at 172.16.2.0 being my primary route. Okay. And also take note that we can use also 192.168. What is that? That 1.2. Okay, let's check that. Okay, so 192.168.1.1. All right, so it's 1.1, and then having an administrative distance of 5. All right, so do show IP route on R2 shows that to reach 10.10.10.0. Okay, so that's 24. It uses our primary link, which was 172.16.2.0. Okay, to reach that network. All right. Now, let's do the testing now. Okay, so by default, this is on. All right. So if we are going to ping this, okay, so from PC1 to PC3 here, okay, it should be successful. All right, and it is. Okay, so same thing from PC3 to PC1, it should be successful. Now, what we want here is we want to really see if it uses the primary route here. Okay, so which is the 10, 10, 10, 0. So let's go back to PC1 and let's try that. All right, so you can do this via tracer. Okay, so go to the desktop and the command prompt. Let's trace it. So tracer, okay, IP address of PC3, which is at 192.168.2.2. Okay, so if you will observe here, of course, the first output of the table is the default gateway of PC1, and then it traverses to 10, 10, 10, 2, which is between R1 and R3, and then going to the PC3. All right, so that means this one is working here. Okay, so also let's try to shut down this interface here. Okay, now shutting down the interface would lead the packet to traverse via R2. Let's do that. Okay, so let's get into R1 here. Okay, and let's shut down serial 0/1/1. Okay, so double check the interface if it is really serial 0/1/1. It is. All right, so let's shut this down. All right, so shutting down. Let's just fast forward time here. Okay, so let's do it again. Earlier on, we traverses via 10, 10, 10, 0. So we are expecting here to traverse via R2 from R1 to R2 to R3 and then to the PC3. Let's see that. So tracer it again, 192.168.2.2 there. Okay, and you've got 4 hops. All right, so that 4 hops, first hop is of course the default gateway. The second hop is, if you will observe, there's 172.16.2, which is the network between R1 and R2 here. And then the next one would be 192.168, all right? So 1.1, which is the network between R2 and R3 here, and then to the PC3. Okay, so that means we have achieved our objective here. All right, now also to test this, you can use the simulation here. So right now, the link or the primary link between R1 and R3, which is 10.10.10.0, is down. All right, so we are expecting that it traverses from R1 to R2 to R3 to the PC3. Now let's do it. So let's click on the simulation here, okay? And let's ping from PC1 here, going to PC3 here. All right, so let's see the movement of the packet here. Play. All right, so that's from PC1 going to R1. All right, and then from R1, it should be moving to R2. All right, and then from R2, you've got route going to 192.168.2.0. It will be forwarded to R3. And then from R3, it will be forwarded to the switch going to PC3 here. But then take note, it's not yet the complete cycle. All right, so we still have to wait for the reply of PC3, which is the destination, going back to the source. All right, so that would be forwarded again to router 3, since this is down here. So that would use the alternate route there, up, going to R2. Okay, and then going back to R1 here, and then forwarding it to PC1. And that would complete the cycle. All right, so that's how floating static route works for R1. Okay, so successful. All right, so the next thing is, let me turn on this interface again here. So let me go back to R1 here, okay, and then go to serial 011. All right, and then we're going to enable it, so no shutdown. Okay, in that sense, that will be enabled, and automatically the packet will traverse from R1 to R3. Okay, so that would use again this primary link set or the primary route set. Okay, so let's do it. Okay, so we are now in simulation. So hoping that this has already been converged. All right. So start. Okay. Add the simple PDU there from PC1 to PC3, and we are expecting the packet will move. Okay. So from R1 directly to R3. Let's play it. All right. So that would be going to R1. Okay. And then move that directly to R3 since this is our primary link. So it works. All right. And then going to the switch 3. Okay. And then PC3. Now the reply would be taking the same path. All right. Since this is the primary link also set on R3, then that would use this link. Okay. So that would be going back. Okay. So to switch 3 to R3. All right. And then forwarding it to, all right, R1 there. Okay. And then going to the switch delivered to the PC1. And that completes the cycle. All right. So that's it. Okay. That's how simple it is to configure the static floating route. All right. Now take note that we also have configured R3 to have the primary route. So same thing. Okay. So if we are going to have it on PC3, let's test it. So you could also do the same, like command prompt. Okay. And then trace route or tracer for the PC. Something like tracer. Okay. IP address of PC1, which is 172.16.3.2. Okay, so let's check that IP address. Okay, so 172.16.3.2 there. All right. So when we do the tracer, we are expecting 3 hops. All right. So because the active link is the primary link, so you've got first hop, second hop, and then third hop. So we're expecting here 3 hops. All right, and that's correct. All right. So the first one would be the default gateway of PC3, which is 192.168.2.1 here. And then the next one is the next hop, which is 10.10.10.1, and then to the PC at 172.16.3.2. Okay. So same thing. If we are going to shut down again the interface, this time on R3, so something like configure terminal. So enable configure terminal. So interface serial 0/1/1. This one is /1/0 there. All right. And then shut down. Okay. So we have shut it down, this interface here. All right. So let's fast forward time. Okay. So let's go back here and then do the same thing. Tracer. This time we are expecting 4 hops because the packet would traverse from PC3 to R3 first hop, to R2 second hop, to R1 third hop, and then to the PC. Let's see. Okay, so you've got 4 hops here. So it worked also. All right. So also you can do the tracer or the packet tracing using the simulation here. So let's do it. All right. So simulation. So this time it's the reverse. So you've got from PC3 to PC1 here. Okay. And let's play it. All right. So from PC3 to router 3. Okay. So that would be our first hop. Since the active link or the primary link is down, so you've got the secondary link. Okay. Catching up the links there, forwarding it to R2. And then R2 to R1. And then R1 to PC1. All right. So again, this will complete the cycle. So once we have received the reply coming from PC1. Okay. And here's the reply now, moving from the PC to router 1. All right. And then to router 2, router 3, and then to the sender, which is PC3. All right. So R2 now, moving to R3. Right. And then to the switch and then to the PC here. So that would complete the cycle. All right. Now that we're done, okay, So let's try to turn on the active link. So let me go back to R3 here, and then to the interface serial 010. Okay, so let's double check this in. All right, that's serial 010 there. And then to enable it, no shutdown. All right, so let's fast forward time and do the simulation again. So this time that the primary link is up, we are expecting that it traverses from R3 directly to R1. Let's do it. Okay, let's add a simple PDU here from PC3. Okay, going to PC1 here. All right, play. Okay, so currently it's now on R3. We are expecting it will be forwarded on R1. Okay, that's it. And then on PC1. All right, and then on the reply, okay, so from PC1 back to R1, and then from R1 traverses to R3 using the primary link set, which is 10.10.10.0, right? And then, okay, let's wait for the packet. All right, so it's now on R3. It will then be forwarded to switch and then to the PC, which is PC3 here. And that completes the cycle. All right, so we already have achieved our objective here, which is to configure, okay, so a floating static route on R1 and R3, okay, so using the given network address. All right, so that ends this video demo on the floating static route. Thank you very much for watching and listening. Have a great day.